Welcome back. This is the second video of the Nature of Light worksheet 4B, which is the relativity of length contraction and relativistic momentum. In the last episode, we did questions 1 through to 3. Now we're going to continue on questions 4, 5, 6, and so on. Okay, so let's start with question 4. Question 4 says the craft is traveling at 98% of the speed of light, and it measures a galaxy's diameter as 400 million light years in diameter. Now, light years is a distance. Okay, it's not a measure of time; it's a measure of distance. So, what is the diameter of the galaxy as observed by an observer, which is stationary relative to the galaxy? Okay. So once again, this is just simply finding the gamma factor and popping into our formulas. So question 4, let's move it into position. Okay. Question 4 has a gamma factor, which is 1 over the square root of 1 minus, it's 0.98 squared, because we're at 98% of the speed of light. So let's calculate that gamma. So that's 1 over square root of 1 minus 0.98 squared, because we're at 98% of the speed of light. Oops, what have I done wrong? 1 over the square root of 1 minus, that's what I'm wrong. Let's try it again. 1 over the square root of 1 minus 0.98 squared. Third time lucky. Good. Okay, so this gives us a gamma of approximately 5.25. 5.02519. There is more digits there. Once again, I'll just keep them on the screen. Right, now our length V is equal to L naught on gamma. There is our formula. Remembering that gamma is a ratio factor. It just tells you what the ratio of LV to L naught is. So as a result, it preserves units. So if this is measured in light years, so will that be measured in light years. So we can put in whatever. We could use miles and miles over here if you want to be ridiculous and work in miles. In imperial units, you can use that. Okay. So let's work it out. Now we've got a galaxy. Now I'm going to put the galaxy as a big box, okay? And the galaxy is moving at 0.98 C. You are a stationary observer out here, and you are looking at. Now let's put yourself as a person in that galaxy. You think your galaxy is normal length, okay? And the normal length of your galaxy is 400 million light years. Okay. You don't see yourself as moving. You see the observer as moving away. Okay. And this observer would see you as contracted. Okay. Oh, I didn't meant to put there. Okay. Right. So we're trying to work out what you would see as the contraction. So it's 400 million light years here. So that's the units divided by 5.02519. Okay, and this gives us 400 divided by that last answer as 79.5999, which is close enough to being 79.6 million light years. Remember, the units are preserved. Okay, let's move on to question 5. Right. Question 5. Okay. A galaxy is measured to be 120 million light years across by a stationary observer. Okay. Calculate the diameter as measured by a traveller moving at this. Okay. So it's the same question as before. You're now the one that is in motion. So therefore you see that you are this person up here, you are the one in motion, and you see the length of that that galaxy has been contracted. Okay, so let's work it out. So you're going to calculate the diameter of the galaxy as measured by a traveller at 0.85 c. So what we need to do firstly is get the gamma factor. So the gamma is 1 over the square root of 1 minus 0.85 c. Oops, shouldn't put that. Oh, it's squared up there. I'll just remove that so there's no problems. So it is 1 over the square root of 1 minus 0.85 squared. So our gamma for this one will be 1.898. Okay, and so on. And so we're going to use LV equals L naught on gamma, which is now the proper length, the length that it should be is 120 million light years in diameter, dividing by 1.898 and so on. We would get, let's have a look, 120 over the answer there, 63.21 million light years. Okay. Right here. So that's A. Okay. Now, let's work out the time needed to cross that the galaxy. So it says here, we're going to use V equals D on T, which is just a normal velocity formula. Velocity is distance over time. But if we're using light years as our units, if our measurement of distance is in light years and time is measured in years, then this formula here gives you the percentage or the decimal of light. Okay, so we're going to use this formula to determine the time that we should be able to cross this galaxy if traveling at that speed there. So time would equal distance over velocity. Okay, so remember I've given you velocity is equal to distance over time. I've just swapped these two values across. So that time, now this time will be measured in years if I measure D in light years and V in a percentage of C. Okay, so D is the distance of this galaxy. So the actual distance that we are measuring the distance of this galaxy as 120 million light years. So that's 120 million light years over the velocity, which is a percentage of C, so it's 0.85 C. Okay. Now, light years divided by C gives you years, because light years is defined as the time taken to travel, is the distance travelled by light in 1 year. So the units will cancel to years here. So it's 120 million, 123, divided by 0.85. And so I'm just going to do that. It's 141.17 by 10 to the 6 years, or it's 141.2 million years. Okay. So the time taken to cross the galaxy traveling at 0.85 percent of the speed of light should be, if we don't take into any time dilation, should be taken as 141.2 million years to cross the galaxy. Right, however, will it take that length of time? And the answer is no, because time is dilated. So on the craft, the person on the craft will see time be slowed down. So what they do is, let's go to C here. Here is our craft. It's traveling at 0.85% C. Oops, sorry. I'll move that up. Okay. You are seeing them cross in, because you're the stationary observer, you see them cross in 141.2 million years. However, their clock is going to be smaller than that. Okay, remember, when you measure your velocity, your time out here, it is a longer time than you would measure in the clock in here. So we're using a time dilation, so TV equals gamma T0. We want to find the smaller time. The smaller time is the one on the craft. So it's going to be this one here. Because remember, they see themselves as being proper time. In their frame of reference, they are not moving. It is you that is moving backward. You are the observer. Even though you're stationary outside, you are measuring a longer time than them. Rightio, so it's 141 point, and I'll just use the correct number that's on the calculator, which is 141.176 million years. The gamma factor at this point here, we got the gamma as 1.898, and we are trying to find their time. So it's this number here divided by the gamma. Answer. That number there divided by the gamma factor, which is 1.898, and that is T naught is equal to 74.4 million years. Okay. Right, so what this means is they will only take 74.4 million years to cross that galaxy in their time. Okay, they will see only that much time go past in the clock. Now, why does this happen? Well, they're also seeing that the galaxy is not as big as it is. They see the galaxy only being a much smaller thing. Their length contraction. They will see the galaxy as length contracted. Okay. But yeah, we might stop there and we'll go to the next video for questions 6 through to 9.